Okay, so we are discussing is software development. In case if you can't listen any of the part, you can please play back the video some other time. So software development, chapter 30. This is part of P4. Now we'll be discussing over here. Obviously, first of all, is you do know that there have been different program generators that have been developed and different program libraries that have been developed, such as the dynamic link libraries. These libraries were made so that the programmer did not have to type in the procedures and the methods again and again. So they're built in within IDEs and softwares. You can find the DLL file within your computer as well. The DLL files are always updated in the next versions that come in every software. Program generators tend to explain what are interpreters, what are compilers, what are assemblers. Assemblers obviously convert from an assembly language to the machine code. Interpreters and compilers, obviously, as you know previously, what they do is they convert high-level language into low-level language, source code into object code, and compilation and interpreters, as you know before, that what the differences are in both of them. So both of them will be converting them into an executable code, so on and so. So why errors occur and how to find them? Okay, we start from this. There are multiple reasons, because since we are going to learn advanced programming, there are reasons why you would face them. One of the most common mistake, as mentioned here, is that the programmer has made some mistake. This could be due to less knowledge in the programming skill, or this could be obviously because of a human mistake. The second most important thing is the requirement specification. If they're not drawn up correctly, and if you're not sure what you're supposed to do, then obviously errors will occur. So requirement specification is a very essential thing. And this is the reason why project management and system lifecycle plays a very vital role to identify what the requirement specifications are. Your system lifecycle, or the system analysis and design, is, as we have studied before, means it's a process through which system analysis and design, or system lifecycle, from your analysis till from your analysis you start away analyzing, and till your future development, you know what you have to develop. So if the requirement specification, if you know the objectives, if you know what has to be done, then there will not be any problem. Otherwise, you will obviously face problems. Okay, it's more like once you get a question, you should obviously know what the question is. Once you know that you have to type an algorithm pseudocode, you should have an idea what you have to do. If you don't know what you have to do, obviously you will not be clearly identifying it and making it sure it works. The software designer has made a design error somewhere in the front end that you're developing. You probably did commit a mistake while designing the front end, the combo box or the radio buttons that you made. Their references were not given properly. Okay, they were not linked up properly from the back end, so on and so on. The user interface is poorly designed, and user makes mistakes. It's obviously it's your responsibility. You could not make a very properly designed user interface, and due to which the user keeps on committing that mistakes, and these have to be rectified. So these are the reasons why errors are occurring. We need to know why they're occurring and why we're talking about them, so that and the next time we don't repeat them. Computer hardware experiences failure. That could be some other reason as well. Okay, so obviously when the user uses it, we will tend to know what the errors are. Okay, so that's why we always have to go through testing, and we have to let the user test it. And this is the reason why you always have a beta version and the alpha version coming in. This is why you come across your black box testing and the white box testing. All these methods basically help you to identify the errors. The testing methods, we will just discuss them. And this is why we always also refer to the dry running. Like we always say that before we actually run a program pseudocode, we should dry run and test it. And we should always I will draw or write down or note down the outcomes of the dry run in our trace table. Okay, so in a trace table, like for example in the for loop, if you want to know how the inner and outer for loop works, okay, you have a for loop here and you have a for loop here. So if you want to see how does the inner for loop work and how does the outer for loop works, if you do dry run testing, you will have an idea. You will see that every time this is not fulfilled, it will come out and it will execute this. So obviously with the help of trace table, you can identify what the output will be and you can do it on a trace table. Okay, so running a program and dry run testing at times is known as walkthrough. Obviously, these are the generic keywords that you should be aware of as far as your P4 is concerned. So when the entire software or the system is basically tested in one go, this we also call it an integration testing. Obviously, integration means joining it together, which means the input, the process, and the output, we can join it together and we can integrate it all together, known as integration testing. Alpha testing basically tends to be when the testing, like I told you before, that when it's inside the software house. When you test the software inside the software house by the software testers, it's known as alpha testing. Okay, alpha testing is very, very essential. We just can't launch the software just like that. It has to be tested by the people who have developed it. Okay, so the customer will check that if it meets their requirements and works as expected. This stage is referred to the acceptance testing, which means obviously the testing that we are doing, is it fulfilling all the requirements that we wanted? So acceptance. We will accept it, we will approve it because it is fulfilling what we wanted it to do. Okay. After your alpha testing has been done, you turn over to beta testing. Beta testing basically means that you will be giving the software code, the software basically outside, and you will be giving it to the users to get a feedback. So you might have seen that whenever Windows, maybe a long time Windows did not release their version, but whenever they do, they always release the beta version. And you might have noticed that the final version appears few months back afterwards, because the users are the best testers, and when we submit the error report, they will find out from hundreds and thousands of users around the world that, okay, these are the common errors that we're facing. They'll make a list and they'll rectify them. So once we get an error message and it says, do you want to send an error report? This is what it means. By sending an error report, we are informing them that at what particular line, at what particular state, at what particular procedure, there was an error and how we tackle that. There are always test plans that will be there, and test plans need to be followed. The reason why we create test plans is not just to have an organized way of testing, but rather there's more to that. For example, test plans would help any new tester to know what has to be tested. What you do is you hire a new tester who joins your organization or your software house. You will ask him or her that, you know what, you have to test the software, the system or the software. If you have a test plans ready, you will just give the test plan to that particular person, and the person will follow the test plans. So you will have a routine, a built-in, an organized way to test your softwares. If you follow the test plans, you will not ignore the most important and the crucial things that need to be tested. Otherwise, if we generally ask someone to test, they might ignore some of the most important things, and we can't do that. So test plans have been designed properly. They have been thoughtfully designed, and then they are given to the testers to follow that. Okay, so these are why test plans are. And test data, we will just discuss that. I'm pretty sure you know what this is, but I'll still discuss it before we start with programming at advanced. Obviously, this is important, you should know. So, Okay. We therefore need to test. We need a test plan. In the first instance, an outline plan is designed. For example, flow of control. Does the user get appropriate choices, and does the chosen option go to the correct module? Okay. You select one particular thing. Is it going? If you click on a button, does it go to that particular report? What you're doing, procedure that you're trying to adopt, is it being fulfilled? Validation of input. Whatever you're trying to enter into the system, whatever you're trying to into the system, is it properly being validated? So validation of the input is obviously something really important. Do loops and decisions perform correctly? Okay, so uh, you, let's say, an example of decisions that I just want to give you an example of the loop within the program. Uh, Perform a particular procedure 3 times. It should not apply because in graphic softwares, this usually happens that you have to press some certain keys. Okay, some performed decisions have to be made. If you don't do that, then it will not work. There are loops that have to work on. If you open up multiple documents, do the increment by one. Okay, so on and so. We have to see are these things working properly or not. Okay. For example, let's say in graphic software such as Photoshop, you use Control Plus to increase the brush size. Are you actually increasing the size or not? Okay. So there are things that you have to see. Is data being saved correctly? Does the system produce the correct results? Obviously, that's important. So obviously, in order to do all this, you need to test the data. Data is the most important thing when you're doing it, and you need to see the data is being properly stored in your database. There are 3 kinds of testing, which I'm pretty sure you're aware of, but let's revise it. Normal testing means that your data will always be in a normal range. For example, you want to enter a price which is between 10 and 50. Now, if you enter a 20, that will be obviously be normal. It's acceptable. You enter 30, that's normal as well. So values that lie within the range of values that have been written down, that becomes normal. Abnormal means that if I enter 60, 60 is not in the range. Or if I enter over here is ABC, that's also abnormal. So abnormal is that are not part of the data values and should not be accepted. So while we are testing, your abnormal values should not be accepted and your normal values should be accepted. Then you have extreme boundary. In extreme boundary, we usually say that there are two. We call them as a low boundary, and we always call it as an upper boundary. Remember, lower boundary and the upper boundary that we usually talk about is always considered as normal as well, which means the 10 value is the lower boundary and 50 is the upper boundary, which means 10 will be accepted, 50 will be accepted, but these are the extreme limits. Okay, so these are the 2 extreme limits that we define to define the boundaries till which we can stretch our range. So, for example, over here, normal value 7 is odd number. So just to give you an example, values that are not allowed, any element that's not allowed, only whole numbers allowed, boundary that comes in the boundary, basically accepted boundary is known as boundary. How to prevent them? Obviously, testing. Make sure you thoroughly test it again. Okay. Your program libraries help you a lot because program libraries have built-in methods and subroutines that are tested properly and have contained no error. So if you'll be using a lot of libraries, you'll face less preventing errors. Conventions such as identifier, tables, data structures, and standard algorithms should be used. Tried and testing design techniques such as structured programming or object-oriented design. We will be discussing this afterwards, inshallah. करेंगे इसको discuss. Object-oriented programming. Oops, हमने discuss नहीं किया. हमारा next topic will start from oops. Okay, next class I'll be discussing what object-oriented programming language stands for. Why do we need to create classes? Okay, in programs. What's the importance of creating classes? So on and so. Project management, obviously very important. If you take business studies, you would have studied project management as well. Well, the importance of project management is there because obviously when you start working with a project, if you do not handle it properly, if you do not designate the work properly, if you do not have proper a team with proper project managers, your work might be delayed or obviously have discrepancies within the project. So managing the project obviously is one of the utmost important thing. And this is what we will learn today is how can we make sure the project is managed properly. Once the project is initiated, okay, we have to assign duties to the managers so that they can further on assign duties to the people who will be working on the project. There has to be a timeline that has to be set up. A timeline means we need to tell people that you have to follow through a Gantt chart. A Gantt chart basically represents through barcodes that you have different stages such as stage A, stage B, and stage C, so on. These stages will be completed by different people. So stage A might and this is your timeline. This could be obviously it's in days, it would include hours as well. That's your timeline. So your timeline will be defined over here. This will be displayed within your organization. There will be people who will be working with team A. There will be people who will be working with team B. There will be people who are working with team C and so on and so on. This could be developer, coders, program. There will be people who will be working for team A and team B. There will be people who will be working for TM and TC simultaneously as well. But the point is that if a particular part of like, for example, the initial input form that has to be designed will be designed by the designers from this time to this time. After that, the database needs to be designed. Okay, so database will be started designing from here and go to here. Once the database is being designed, probably in between, we can start developing the reports as well. So some of the parts you can see over here will be going simultaneously. So we can start work simultaneously. Some parts can work in parallel. Some parts will work when one part finishes, then the other part starts. So this is basically known as Gantt chart. I'm sorry, G-A-N-T-T-H. I just can't type it. Gantt chart. But we'll also discuss today is the pulse chart. Pulse chart is another way. Are you listening here? I hope you can hear me what I'm saying. Nimra beta? Khatija?
Yes, sir.
Right, good.
Yes.
Okay, so pulse chart is basically another way in which you can identify the critical path analysis. Very important thing. We'll discuss it. We can define the milestones, the deliverable items. We can talk about that. So we'll just look at it. Let me. Okay. Although this is also good, let me also explain this through. One second. Where's my website? Okay, Perth and CPA. So what is Perth and CPA? Let's say you have to basically assemble is a bicycle. You have the frame, you have the handlebar, you have the seat, you have the wheels. Assembling of the bicycle takes 0.75 hours. So every step has to be tackled. Then you can go to the next step. So a Perth chart can be used. Develop a list of tasks in the table form, task IDs, dependency, execution time. Dependencies basically mean that you will obviously have some of the tasks which will be dependent on some other task. For example, when you're manufacturing a car, you cannot, even if your engine is ready, it's dependent upon the car body if it's assembled properly. If it's not, there's no point of assembling the car engine before it's not done. So it's dependent. Okay, so there are things that are dependent. The painting process of a of a bicycle can only start when the entire bicycle is ready. So, or maybe some other, it depends on the execution time of every stage. Okay, we should know how much time will everything take. Topological diagrams of the tasks, task IDs, and dependency arrows. This is what this will include. Add the task execution time. I'll just show you all that. Determine the project cumulative elapsed time, how much time has been passed till now, till a particular stage, how much time has been passed. Identify the project critical path. Very important thing. Okay, critical path is the longest path that will be delaying the project. Identify ways to reduce the total project cumulative elapsed time, which means we need to work on the critical path and we have to reduce the critical path, because critical path will be increasing the time of the entire project. So let's say I have the following tasks: A, B, C, D, finish. I have the dependency start. Start is obviously not depending. It will take 2 days. And task ID B is dependent on A, C is dependent on A, D is dependent on A. Task E is dependent on CD. The task F is dependent on B, so on and so on. And these are the number of days they will take. Now, if you just have a look at this, what we will come with is, I'll just somehow, just to have an empty space. Okay. So, if I have the task A over here, I do know that I need to have, but just 1 second. I have to take an assessment of the students. Just give me a second. Can you give me, girls? Just better a second. This time. Tajur, can you hear me better? Tajur, can you hear me?
जी सर
ताजु मैं आपके ग्रुप में ना आई एम शेयरिंग द टेस्ट विद यू गाइस. अभी मेरी क्लास चल रही है 1 के स्टूडेंट्स के साथ राइट नाउ. इस टाइम पे क्लास मेरी होती है, तो मैं ग्रुप में शेयर करता हूँ आपका टेस्ट. यू कैन स्टार्ट डूइंग इट राइट नाउ. ओके, 12:10 पे यू कैन हैव द स्टार्टिंग टाइम. ठीक है, मैं ग्रुप में बता देता हूँ आप लोगों को भी.
ठीक है सर.
ठीक है, मैं बताता हूँ बस आपको. ऑल द बेस्ट. इफ देयर इज एनी क्वेश्चन यू कैन आस्क मी ताजु. ओके राइट बेटा?
ठीक है सर. ठीक.
ओके बेटा, ऑल द बेस्ट. मैं शेयर करता हूँ. बेटा आई शेयर द टेस्ट. आप जाके यू कैन स्टार्ट. ओके, मैंने ग्रुप में शेयर कर दिया.
ठीक है सर.
ओके बेटा. अच्छा, so beta I was saying you have the task A. So you can see is के task A, you have task B which is dependent on A. So I can have B here. And B will only be done when A is done. Then I have C again. I have C. C can only be done when A is done. Then I have D. D can only be done when A is done. Then I have E. E can only be done when C and D are done. Then I have F. F can only be done once B is done. Then I have G. G can only be completed when E and F have been completed. And the finish is G. The days that we have to mention over here, that this A, from start to A, this will be taking 2 days. Okay, so we can write 2 over here. And B will be taking 4, so we can write 4 here. We can write 6 here. So we will be writing the days right over here. Okay, how much days will each and every stage take for it to get completed? And this is how basically your per chart is made. A pretty simple way, not very complicated. Is it clear, beta? Pretty easy. Yes or no?
Yes.
It's pretty easy. So that's how step by step you will be making it. Okay, step by step you'll be making it. And then you'll be mentioning the time on there as well. Now, once you've done with this, you need to calculate is the critical path. If you look at this, I have over here is 2, 7, 11, 13. One path is this, one path is 8, 11, 13, one path is this. So if you look at these times, okay, so every path, or look at this one, A, C, F, I, A, D, H, J, A, D, G, J, A, E, H, J. Okay, so in all of these, you can see 21 weeks, let's say 21 weeks are taken for this. So it's a critical path. The path that will be taking the longest path, कौन सा भी होगा? Assume कर लो, for example, this is the path. This is the path that takes the most of the time. We will call this the path, the critical path. Why the critical paths are important? Because critical paths are the paths that will be delaying the project. So what happens in project management is when this happens, we will allocate more resources. इसलिए मैंने पहले जो बात की थी कि when we start with project management, we will always take care of one thing. कि when people are working on project, initially when I started, दूसरे में था, sorry, it was in the book, that ये हो गया ना. Managers will obviously allocate people to different tasks as well. If a person A is working and has done his work, will be asked to work with team B as well. And this is the reason why when you work for software houses these days, they don't only ask you that you should know coding and programming, they'll also ask you, do you know designing as well? The reason why is they want people who can work on multiple tasks. Because let's say you're a coding and programmer and there's no other project coming in. So they don't want you to sit idle for days or weeks because you don't have any work to do. They want people who can be used and utilized in other parts, and they just want to finish the project so they can get more projects. That's the way they make business going. You get the point. So allocation of resources mean human power, has to be allocated sensibly in such a way that no one is wasting the time, and the critical paths have to be reduced by allocating more resources to the critical path, and that's how we do it. So these are the key points. I will share this presentation with you as well in the group. Okay, so that's the key points. Yeah, the benefits of the CPM you should know. It's visual representation. The project plan can be tested to ensure it worked out. Identify the key tasks, so on and so. So many the key points of the path. Disadvantages can be more difficult to understand than Gantt chart. Yeah, and in a way, yeah, for everyone to understand, the time needed for tasks is not clear as in Gantt chart. Like I said, Gantt chart, as I was discussing, it's a very good representation of timeline, time with bars. You have bars over here. Anyone can have a look at it, and they can walk in. They can say, okay, this is the day, and we have to start working on this. The next day they come in. Oh, you know what? We just have 2 days left. We have to complete it. So they will have an idea at a glance. They know what they have to do. So it's obviously it's a very good way to work with it. Okay. There's another terminology which is not mentioned over here, which is basically known as the float time. In this, we also have something known as float time. The float time is basically the shortest time that particular project, the part has been completed. For example, we just talked about the longest path. The shortest path that we will have is the float time. Talk the critical path, Gantt chart, that's Gantt chart, that's Gantt chart. Producing design, you see some are working in parallel integration installation, very good example as well over here of Gantt chart. I explained to you. So we've been able to discuss it. ठीक है, अब इंशाल्लाह हमारा जो अगली डिस्कशन है, we will start with object oriented programming. और अब आपको साथ साथ मेरे you need to start working with Python. Okay, हम एक फ्लो में जाएंगे कि so that हम प्रोग्रामिंग आसान हो जाए. मैं आपको ऑब्जेक्ट ओरिएंटेड प्रोग्रामिंग पहले समझाऊंगा and then we can start working with for the programming and on and also. Okay, so ज़्यादा टाइम इस पे सिर्फ तब लगेगा कि you need to get acquainted with Python. Right, beta? Any question? Was pretty easy chapter today. Wasn't complicated, by the way. मगर we done with 30 at least. Yes or no? Who was absent today?
Yes, sir.
Who was absent today? Oh, one. Yes.
Sir, Zamna.
Yeah. चलो बेटा, keep on working hard and be in touch with me. Okay? फिर हम इंशाल्लाह ट्यूसडे को डिस्कस करते हैं इसका नेक्स्ट पार्ट. Right. Okay, बेटा. See you then. जल्दी डिस्कशन हो गया because you've done this short one. Okay. अल्लाह हाफिज.
Allah, sir.
अल्लाह हाफिज बेटा.